Okay, to express 0.888 recurring as a fraction, we proceed as follows. We take this recurring decimal number and call it x, for example. Doesn't have to be x. We now need to multiply both x and the decimal number by a power of 10 such that the decimal part repeats itself. So the digit, if you look at the decimal number, the digit that repeats itself is 8. So we need to manipulate and multiply x by power of 10 until we get the decimal part 8 to repeat. So because only 8 is repeating over here, we only need to multiply by 10 in order to move the decimal point from its position here to that position over there. And by moving the decimal point one position, we're multiplying by 10. So 10x equals 8.888, and all this will recur. Now the decimal, let's just write the x underneath that. Now you can clearly see that the decimal part repeats, right? Ad infinitum, to infinity. It's non-terminating. So if we now subtract the bottom expression from the top expression, the decimal part, everything after the decimal point, 0.88888, will cancel out when we subtract them. So 10x minus x will give us 9x. 8 minus 0 give us 8. And 0.88888 recurring minus 0.88888 recurring will be 0. So all we're left with is 9x equals 8. We can now divide both sides by 9. X equals 8 over 9. 8 over 9, check on your calculator, will be 0.888 recurring. So we've written and expressed a recurring decimal number as a rational number, as a fraction. Write 0.24, where both decimal digits 2 and 4 recur, as a fraction. 0.24, where they both 2 and 4 recur, is 0.24, 24, 24, 24, etc. So we're going to let x be this number, 0.24, 24, 24. We now need to multiply x by a power of 10 such that the decimal digits recur in the same position, right? 2 and 4 both recur. So we can't just multiply by 10 because then we would have 2.42424. But we need both 2 and 4 to recur. So we need to move the decimal point not one place to the right, but 2 places to the right, because then we have the decimal, the numbers, the digits after the decimal point will be 242424, and that's exactly what we want over here. So we're going to multiply it by 100 now, because we're moving the decimal point 2 places to the right, and there are 2 zeros in 100. The number of zeros that we multiply by, power of 10 we multiply by, will tell us how many decimal places we are going to move to the right. So because we're multiplying by 100, we're moving 2 decimal places to the right. Rather, to be more accurate, we need to move the decimal point 2 places to the right. Therefore, we need to multiply by 100. So 100x will be 24.2424. Now I'm just going to write x underneath that just to make the subtraction look a little bit easier. We're now going to subtract these two expressions, because we'll look at the decimal parts. Everything after the decimal point, 0.242424 recurring, we have that in both expressions. And when we subtract the expressions, that part will cancel. So 100x minus x is 99x. 24 minus 0 is 24. And the decimal part will cancel. That's the whole purpose of doing all of this. We can now divide both sides by 99. So x equals 24 over 99. This is not the simplest form because 3 goes into both. So we can divide both 24 and 99 by 3. 24 divided by 3 is 8, and 99 divided by 3 is 33. If you punch 8 over 33 into your calculator, you will get 0.2424 recurring. Write 0.366666 as a fraction. So 0.3, the only decimal that is recurring here is the 6. So we actually can put a dot over that 6. Another way of writing that, as it's written with this ellipsis, is just 0.3, but the 6 gets the dot. That dot on top of the decimal digit means that digit will repeat. 3 is not repeating, and therefore the dot does not go over the 3. In the previous example, we got 0.24 with a dot both. That means that 2 and 4 both repeat. In this case, only the 6 is repeating, so the dot will only sit on top of the 6. Ever see this in the exam? That's what it means. So we are going to let x be 0.3666 recurring. Now, because 6 is the only digit that repeats, we cannot move the decimal one place. Well, we're going to have to manipulate twice here, because if we move this decimal from where it is over there, we're going to get, if we multiply by 10, we'll get 3.66666 recurring. But we have x on its own is 0.3666. Now we need the decimal part to cancel out. So the decimal part, in other words, everything after the decimal point has to be identical in order to express the recurring decimal number as a fraction. So the first thing we're going to do is move the decimal point one place to the right to bring it into this position, because then we'll have the digit 6 recurring. So the first thing we're doing is multiply both sides by 10. So that 10x equals 3.6666 recurring. Now we can't say 10x minus x, because the decimal part here is 0.366666, but the decimal part here is 0.666666, and they're not identical, therefore we can't subtract them. So we now have to multiply this 10x by another 10 in order to move the decimal from there to there, because in that case we're going to get the digit 6 recurring again. So we will have 100x equals 36.666 recurring. Now if we look at the decimal part for 10x and the decimal part for 100x, it's identical. So when we subtract these expressions, the decimal part will subtract to give 0, but cancel out. So we just are going to write 10x underneath that, just to make the subtraction look a little easier. And now we're going to subtract these expressions. So 100x minus 10x is 90x. 36 minus 3 is 33. And the decimal part, 0.66666, minus the decimal part, 0.66666, will cancel. That is why we are doing this. So 90x equals 33. We now divide both sides by 90. X is 33 over 90. That's not the simplest form because 3 goes into both 33 and 90. Divide by 33. 33 divided by 3 is 11. 90 divided by 3 is 13. So 11 over 13 is this decimal number, 0.3666. Okay, to write 0.083 recurring as a fraction, and look, the dot is on 3 above the digit 3, so that means the decimal number is 0.083333 recurring. So we're going to let x be this decimal number, 0.08333 recurring. Now because 3 is the recurring digit here, we need to move the decimal point to a point where the decimal digit 3, will again repeat, again recur. So we can move it 1, 2 places to the right, so once in that position there. So we're going to multiply by 100 and 100x. So 100x equals 8.333 recurring. Now the decimal part here, 0.08, or rather the decimal part 0.8333 is not the same as 333. So we need to multiply, manipulate the 100x by, and multiply by another power of 10 in order to move the decimal point further to the right. So 100x times 10 would be 1000x. We'll move the decimal, because we're multiplying by 10, we can move the decimal point 1 place to the right. So we would have 83.333. Just write the 100x underneath that to make the subtraction look easier. We're now going to subtract these two expressions. 1000x minus 100x is 900x. 83 minus 8 is 75. And 0.333, rather than the decimal part, 0.333, will subtract, will cancel out. So 900x equals 75. X equals 75 over 900. 15 can go into both 75 and 900. So x equals 5 over 60. 5 over 60 as a decimal number is 0.083.